Okay, thanks. So I hope you're not too exhausted. I will try to do the job that Axel wants and steer up multidisciplinary work. So as the previous speaker, I'm presenting a big work of a collective researcher, and this work was done the last few years, and I have to acknowledge all the co-authors. There are people from climate modelers, as I am, people from niche modeling, and people from paleontology and palynology, so it's a huge community. So the next slide I present to you the two important topics I want to describe today. The first is concerning the dispersal of Australopithecus from mid to late Pliocene. And this is quite interesting because I will show you that we can say something about not only the place where they live, but also the possibility for them to disperse. And the second topic is much deeper in the time. It is linked to what I call the ape saga. That means the fact that the apes during the Neogen, they get outside from Africa and went to Europe and Asia, and this is also clearly linked to climate changes. The next slide is just a very brief summary of the geological forcing factors. Because we are talking now about millions of years, we are obliged to account for geological events. So on the right side of this slide, you can see something that has crossed all my career, which is the shrinkage of the Paratethys. This is a very huge geological phenomenon that completely transformed the climate of the Earth, and especially in Europe and Asia and Africa. I will show you that in a moment, but what you see here is that this shrinkage makes a huge epicontinental sea, a little sea like the Mediterranean, and we don't think about it, but it's really very important. Another important feature, of course, that Kyung mentioned the first day is the uplift of the African rift. The uplift of the African rift is very important to change the aridity in the Eastern Africa. Previously, Molnar and Kane attributed this aridification of East Africa to a far-field cause, the Indonesian through-flow change. And this was true, but it was not the only explanation. An important explanation is linked to the uplift of the African rift, which changes the hydrology. And a good place to see these changes of hydrology is the Chad Lake. And I will come back on this Chad Lake just in the next few slides. The next slide is an important result that comes from a paper published by Zhang some years ago that explains two important things. When you get a huge epicontinental sea like the Tethys, you don't get important monsoon, just because in summer it's not so hot because of the sea, and in winter it's not so cold because of this sea. So in fact, you don't have a big monsoonal climate as we have today. Reversely, when the status shrink to the present-day Mediterranean, you get a huge change in Asian and African monsoon. This is an important result, but the more important result that he published here is that the sensitivity of your climate to precession changes is very, very important today. It has been shown in the previous slide, so I have not to comment too much on that. The next slide is why Chad Lake is so important for us. It is important, as you will see in the next slide, it is very important because, contrarily to what people thought before, because most fossil records were to the east of the rift, there were also Australopithecus and human ancestor west of the rift in the Chad Lake. The Chad Lake becomes a mega Chad Lake during humid period, and what you see here, it's the result of Camille Contou, a former PhD of mine. This is the fact that during humid period of the Pliocene, you can have a mega Chad Lake, which corresponds to 400 square kilometers. That means about the size of the France, and during this humid period. And these lakes were there, and if this is the other panel on the right, if now in your simulation you prescribe this mega lake, and you use a climate and vegetation model, you can show that you get over surrounding this lake a vegetation, and this mosaic vegetation supports the fact that there were indeed Australopithecus there, as for instance Abel, which has been found 3.6 million of years. Okay, so this is very interesting. Now I will discuss really the topic of this year, which is the suitable ability. So the next slide is what we did. We take a simulation of Pliocene 3 million years ago with a global model. There is an exercise called PLIMIP, which intercompare different global model climates for the mid to late Pliocene 3 million years ago. This model, they get a spatial resolution of about, let's say, 1 to 2 degrees. And so what we do, we take the sea surface temperature extracted from a coupled model, and we need to downscale to go to tens of kilometers to use niche modeling. So what we did, we take the only atmospheric model alone, but with very high resolution and coupled to a vegetation model. And from this simulation, we use a niche modeling, here it is Maxence, at tens of kilometers to investigate the suitable ability of the Australopithecus. So what you see here, it is the suitable ability for a normal climate of the Pliocene belonging to Pliocene 1. And what do you see here? You see there is 3 spots, in fact, and a large band from the Ethiopia to the Chad Lake. So there is this region, which is low to mid suitable ability, and you also get South Africa. So this corresponds to the fossil records, but so we are quite happy. By the way, you see there is also low to mid suitability in Madagascar, where at my knowledge we don't find anything, or near the Mediterranean, but we get the 3 main important regions. And the next slide shows you what happened from 4 to 3 million of years. So from 4 to 3 million of years, we consider that the CO2 doesn't change. There is no major tectonic change. So the most important things is the orbital change, and as I told you before, the precession things. So we perform 4 simulations at different orbital forcing of the precession, and we look to the deformation of the suitability of the habitat. And as you can see on this slide, there are 4 different precession values. You see that in fact this band that you see at 15 degrees north is just broken. What does that mean? That means that depending on the precession, the region of the Chad Lake was suitable or not. So it was not always suitable. And then you can see the refuge area on this plot, and it corresponds to the place where you always have a low to high suitability during all the precession cycle. And there are only 2 areas, Eastern Africa and South Africa. And the Chad region is only partially and periodically suitable. So this is the end of the first story concerning Australopithecus. Now we are going back in time to Miocene period, and this is an important issue for climate, and we are discussing about outscape from Africa, so I will come back to outscape from Africa, but much deeper in the past. So on this slide, what you see, it's the evolution of the fossil record. It's an old slide, but I will show next another slide which is much more recent and much more appropriate, I think. So on this slide, what you see that the apes, 23 million years ago, at the beginning of the Neogene, they lived in the tropical forest. And a big advantage for us, because of course I'm just a climate modeler, so I don't simulate the apes in my model. The only thing I really can simulate is the forest, tropical, subtropical rainforest. This I can simulate. So the big advantage in comparison to what we saw this last day is that the apes are infeodated to this forest because they need fruit all the year. So at the beginning of the Neogene, they lived in the tropical forest of Africa. And then, around 17 million years, when there is a mid-Miocene climate optimum, we know from paleontologic record that this forest spread, and it is the first escape of apes occurring at that time. Unfortunately, the mid-Miocene climate optimum didn't last long, and it becomes cooler and cooler. And due to this cooling, the forest regressed, and the apes has to go elsewhere, either coming back to Africa or staying in Asia. And finally, they arrived during late Miocene in southeastern Asia. Okay, so next slide shows you a more accurate, just as the previous speaker beautifully explained the complexity. It is true, there are different routes, different periods to get out of Africa, even during mid-Miocene. It's exactly the same story, more or less, than it just talked you about. So here I show the different possible routes that we get now from fossil record. As you can see, there is different scenario with different fossil records. At least there is 3 important scenarios. One is due to the fact that it is possible from South Arabia to go from Africa to Asia. So there is a first route, a first pathway that comes from this place to East or West Europe. Another possibility is to go from Ethiopia to Greece, and the third possibility is to go from Somalia to Pakistan. All these routes are possible in the time. What is really important here is that the apes, to do this travel, to do this long journey, they need food. They need a good environment, an appropriate environment. So the next slide is just to do that, because we are just climate modelers. So what we want to show here is that doing Miocene simulation, mid-Miocene simulation, we do climate simulation with correct paleogeography, CO2, and we try to understand the climate and the hydrology. So on this panel, what you see at the top, you see that over Europe, during mid-Miocene, the temperature was higher. So this is good for forest and subtropical forest, but it's not enough. If it's very cold the winter, it doesn't work. So the second panel shows you the seasonal changes that we compute during Miocene compared to today. And you see that the seasonal cycle is very damp. So this is also very favorable to get forest. So 2 diagrams at the bottom show you the hydrologic cycle, because to get forest and tropical or subtropical forest in Europe, you need a lot of water. And we simulate that there is an increase of precipitation and evaporation. All this is interesting, but the best is really to simulate the forest and the vegetation. So the next slide, we have done that, the next slide with a model, a vegetation model called Caraïbes, which was fitted for Miocene, so quite appropriate. And I'm sorry, you will see the extent of a tropical forest. It should be in green, but it's in red. But what you can see that indeed plugging our climate model result from mid-Miocene with this vegetation model Caraïbes, we indeed simulate what is known by paleontologic record, a real extent of tropical forest over Europe, and this is absolutely necessary for the apes to escape. So the escape out of Africa, whatever the pathway they choose, is really related to climate changes. And now I come back to finish with suitable ability, and the next slide show you the suitable ability that we compute. So the way to get this slide is always the same. We get a coupled simulation with a spatial resolution of 1 degree. We extract the sea surface temperature, and then we downscale with an atmosphere-only simulation coupled with a vegetation model, and we feed a niche model, and this niche model, which is based and calibrated with the data completely independently from the simulation. And so here I show you the suitable ability at 17 million years. At that time, the apes, they already get out from Africa, and you can see that they are there in Europe and Asia. So this is a good news. And then there are 2 reasons why this can evolve: the climate and the evolution and adaptation of the niche. So On the other plot, you can see what will happen if you take the climate of 14 million years with a niche that doesn't change. And you see important change over the Mediterranean basin. Now, let's go to the 14 million years. It is much cooler. It's difficult. It is just impossible for the apes to stay in the forest of Europe because there is no more forest. They have to go back or to go on the eastern side toward Asia. So you see that on this slide, at the 14 million years, there is no more apes in Europe, so this is okay. And also what you can see is that if you use the niche of 17 for 14, anyway, you will have some problem to find in Central Africa apes. What does that mean? That means that there are two important processes, because it's not several kilo years of evolution. It's 3 million years of evolution. So the niche may have evolved, and this is what we are doing. It is still work on progress to disentangle the climate impact from the niche evolution impact. So now I go for some conclusion. So I will just summarize for the mid-Pliocene what we show for this period between 4 and 3 million of years. We can simulate correctly the different regions where we find Australopithecus. We can even show that due to precession signal and to major hydrological changes, in fact, there is only 2 regions that are perennial, South Africa and Eastern Africa, and periodically only Chad Lake region. And concerning the long journey of apes, we can show that indeed the mid-Miocene climate optimum was a period which was really appropriate to get out of Africa, but we are still unable to know exactly how this happened. So there is, again, much more work and progress to do to get a better and more realistic picture of what really happened. Thank you very much.